Dear student, today we discuss the trigonometrical integration and the type of the sine t power n and cos t power n and both the function sine and cos, where the power of the trigonometrical function sine and cos is odd power m or n. One of them is the odd power this type of the integral when the power of the trigo function and the sine cos there is a odd positive integer, then the method is we distribute the odd power in even and odd function. That means like this is our function sine t power nx dx, and where we distribute in even and odd. First rule is distribute the given power in even and odd so that the integral change into sine has n minus 1 power and x and multiple is sine x dx. And this part, because n is odd and n minus 1, this part is even, so we can write in this function in cos x. And second step, the step of the method is this part, the even part, let the even part is new variable tub after changing into cos x. This part can be written in a cos x, and this one is assumed as a new variable t, and so that this part, because the derivative of the cos is sin x dx, so this part change into dt, and this is the t to the power some power. So we expand this by the binomial function. So we try to learn this type of the integral by an example. So I take a question. Let the I integral is sine power 3x dx. Yes, here we can use another method because the power is small, so we can use here angle formula, that 3 theta also. But if the power of the sine and cos is so higher, then we use this method distributing in even and odd function. So we distribute it in even and odd part. Sine cube is written as sine square x and sine x dx, and this part sine square can be written sine 1 minus cos square by trigonometrical identities, and multiple is sine x dx. And now we use here the substitution method. So assume that cos x is a t variable. Let cos x is equal to t and negative sin x dx is equal to dt. So this part sin x dx change into negative dt, and this value is t. So right here negative 1 minus t square dt, and now we easily solve this part by the formation algebraic function. So right here the integral value I integral is negative integral of 1 with respect to variable t is t, and negative t square integral is t cube divided by 3, and in the constant is c, and now put the value of t is equal to cos x. That is our final answer. So the I integral is negative t is equal to cos x and negative cos cube x divided by 3 plus integral constant c. That is the method. Here we can use by the angle form of the 3 theta also. But when the n and m are high power, then the angle formation is not useful and we apply this method only. So I take another example. Let the I integral is equal to sine square x and cos cube x dx. Okay, and here this power is r power, so we change this function in even and r and write here sine square x, this cos square written as cos square x and cos x dx. Now this part cos square x can be written by the identity in 1 minus sine square as a function of sine, so that the substitutions the sin x is a t will be applied. So write here sine square x multiplied by 1 minus sine square x and cos x dx here, and cos x is the derivatives of sin x, so we assume this sin x and this one as a t variable. So the next step is let sin x is equal to t and plus derivatives of cos x dx is equal to dt, and this remove I integral is t square 1 minus this one also t square and cos x dx change into dt, and the solution is t square minus t4 dt, and by the formulation integral of t to the power 2 is t raised to 3 upon 3 minus t raised to 5 upon 5 plus constant c, and the value of t is sin x, so the I integral is equal to sin cube x divided by 3 minus sin x to the power 5 divided by 5 and plus constant c. So this is the trigonometrical integral. The type 1 is as following method, and when the power n is even, that for small power we use the angle form as a 2 theta 4 theta, but when n the higher, then we use here for even power a De Moivre's theorem. So for small power, if n is even and small, then use angle formula, and we can solve this both type of the integral as shown. So let the example I is equal to sine square dx, and here the power is even, so we change into angle form by this formula, because cos of 2x is 1 minus 2 sine square x, and here the given value is sine square, so the value of sine square is 1 minus cos 2x divided by 2, and put these values here and directly we solve 1 minus cos of 2x divided by 2 dx, and both the term has integral. So the I integral is, and the integral of 1 is x here, and integral of cos 2x, because the derivatives of sine 2x is cos 2x, and so write here sine 2x, and the coefficient of variable is divisor of the term plus constant c. This is our final solution. Yes, student. We will solve the high even power in next video. Thank you for watching.